Welcome back. Let's start by creating the project structure in order to achieve a better separation of concerns in the application, and hopefully the code will be more readable, therefore easy to follow. So let's create three packages: the data, DI, and UI. Now move the main activity into the UI package. Then let's create a new class called face detector application. It's a custom application class, meaning it gets created when our application starts. The Hilt Android app annotation is crucial here. It integrates Dagger Hilt into our app for seamless dependency injection. In simple terms, it makes managing objects and dependencies easier. We have to specify the name of our application in the manifest, and with this we are ready to create our activity module, which is a class that will allow us to provide dependencies for the main activity. The first dependency we are going to provide is text to speech, which is a service, uh, a bridge between our app and the user, converting text to audible speech. We are ensuring it speaks in a US English accent. The next instance we are going to provide is executor service. Think of this as a personal assistant that handles background tasks for us. It's single thread, meaning it does one task at a time, ensuring our apps are managed efficiently. This executor service will be going to be used for our camera. Finally, face detector, the superstar. We set up with machine learning kits face detection class, opting for a fast performance mode. This ensures quick and real-time face detection. Our app's interface is fairly minimalistic. We have a preview view from the camera ads library, which is essentially a viewport into our device camera. This is where we'll see real-time face detection in action. As we transition to the heart of our application, the main activity, we'll explore the difficult or the hard parts of setting up camera functionalities, permissions, and dependency injection. Let's start by the dependency injection. Firstly, notice the Android entry point annotation at the beginning of our class. This signals that our main activity is ready for Dagger Hilt injections. We are leveraging Dagger Hilt to automatically provide instance of text-to-speech. As I mentioned before, this will allow our app to communicate audible with the user. Face detector, our main tool for detecting faces in the camera feed, an executor service, which is a background service for offloading tasks from the main thread. Now it's time to include the permission logic. Every Android developer knows the importance of permissions. Our app requires certain permissions, especially for camera access, to function correctly. Companion object. Toward the end of our class, we have a companion object. Think of this as a container for constants and utility functions related to our main activity. Here we are creating the required permissions, which is a list of permissions our app requires. Notice how we conditionally add the right external storage permission based on the Android version. The permission is required. So, if the permission wasn't allowed, we have to notify the user, prompting, prompting that the user allow the permission. The check permission status function plays a crucial role here. It checks if all the necessary permissions have been granted. If they have, we fire up the camera with start camera. If not, we proceed to request the permissions. Perfect. Now we are ready to implement the camera setup. Setting up the camera is a multi-step process. We begin by fetching an instance of process camera provider. This class let us bind the camera lifecycle to our app's lifecycle, ensuring that the camera starts and stops with our app. For the preview, the preview class provides a live camera feed. We create an instance of this and connect it to our preview view in the layout. This makes the live feed visible to the user. Now, for image analyzer, while we've set up an image analysis instance, we haven't defined the analyzer logic yet. This will be the spot where we'll implement face detection in future uh, future videos. Here we are creating other constants required. For example, the image resolution we want for our preview. Cameras can be tricky. Devices might have multiple cameras like front and rear. Here we are opting for the default back camera, which, as the name suggests, selects the device's primary rear camera. Finally, with all these pieces, we bind them to our app's lifecycle using bind to lifecycle. But before doing that, we have to unbind all the use cases first. Bind to life cycles. This ensures that the camera starts when our app becomes active and stops when it steps. With this, the remaining steps consist only in specify the required permissions in the Android manifest. Here, we are going to specify the camera permission and also the write on external storage. After that, we are ready to test if our app runs. It's working. Here we go. Now, let's provide the access to the camera, and this is the preview. We are ready to continue in the next video.